Imagine that you're deep in the Brazilian Atlantic forest trying to monitor the local jaguar population. Because according to WWF, is an estimated 73% biodiversity reduction in monitored wildlife populations in the last 50 years alone. Now, to try and monitor the biodiversity, a lot of ecologists use what's known as camera traps. So these are just camera devices that you can strap onto trees, and they get activated when you have an animal coming and passing through. So as the animal comes by, it might be motion activated or heat activated, and the camera trap takes a little picture. Now, it can be quite tedious to go through all of these pictures manually. And that's why there are frameworks with machine learning that can automatically detect and create these bounding boxes around the animals that we can then use to classify the animals as different species, for example. And one of the popular methods to do this is with a package called PyTorch Wildlife. And PyTorch Wildlife, developed by Microsoft, has a detection model called the MegaDetector. And it is pretty cool. So in this video, I'm going to show you how to use the MegaDetector to classify these wildlife images. This is the demo that we will be building. Right here we have some example images from a dataset from camera traps in the Atlantic forest in Brazil. And right here we can see that we have an animal, and if we hit classify, it will run the PyTorch MegaDetector, and boom, it will find the animal and also display what the confidence level was for that animal. And we can try it, for example, with a jaguar too. So if we try and classify this, we can see that it correctly finds a jaguar, and we can do it for a bunch of different images that we have in our dataset. But then again, it might not work as well on other images. For example, we have two birds over here, but if I classify them, we can see that in this case, the model gets pretty low confidence scores, kind of gets the right area for one of the birds, but does not see the other one at all. So with this way, we can also see where our model might be struggling, to also see if we can do anything to maybe fine-tune it or make it better in that sense. Alrighty, so to do this, we want to open a new project, and in our terminal right here, we want to create a new virtual environment so we can install our packages. And we do that with the venv.env, and this is going to create a new virtual environment. And then we can activate this virtual environment using source.env-bin activate. And inside here, we're going to install the required packages by typing pip install and all of these libraries. And after some time, we're going to have them downloaded. And once that is done, we want to import all of those libraries into our Python file. Then we want to import the PyTorch wildlife.models and import the detection model. And just as a side note, we also have classification models, i.e. if you want to take that, for example, bounding box of the animal and also say what type of animal it is, we'd also have those classification models. But here we're only going to use the detection model. And then on this line, we're going to import the MegaDetector. And in this case, I'm using the V6 version. And there's a bunch of different versions that you can find. On the GitHub page for PyTorch Wildlife, we can scroll down and then we can see that right here we have all the different versions that are supported. So right now we're doing the MegaDetector V6 Compact, but there's also different ones, for example, Extra or No NMS, and they have different kind of parameters, the number of, like the size of the model, and also different performances. So you can go in here if you want to know kind of what options there are. And then right here, we're loading in some example photos from the photos directory. So these are the ones that you could click on the web interface, and you can replace these with your own or take them from the GitHub repo and use them for your project too. Then comes the main function, the classify image or kind of the detection model. So first of all, we're going to convert the image into a NumPy array, and this is the required format of the detection model. And then here's the main function. We're saying detection model dot single image detection, and then the image array. And here we're going to get back a result that both contains the detections, i.e. the bounding boxes, and the labels. For example, an animal, a human, or a vehicle. Then I want to go through and draw these bounding boxes and texts on top of them. And I'm going to create a new function called drawInfo for that. So the drawInfo function will take a drawing kind of object, the image that we want to draw on top of, the bounding box that we detected, and the label. And first we're going to get the size of the image so we can dynamically size the border of the bounding box and the size of the text depending on the image size. And this is exactly what we're doing here. Then to work with the draw, I'm going to have to load in a font. And as you can see here, I'm using the Arial Unicode font. And you can find these on your Mac from the font book, or you can just download them from the repo or anywhere else online. And then the bounding box comes in xmin, ymin, xmax, ymax coordinates. So we're just pulling those out. And then we're drawing the rectangle with the red outline and the border size, and then the text to get our detection. And finally, we'll be using Gradio to build our little web demo. So to do this, we're going to say with gradio.blocks as a demo, and this will be the title that you can change to whatever you want. And then we're creating our row here. And this is really the key thing that we're going to say. We're going to have an input image with the image that we want to perform the detection on, and then the output image containing all our border and bounding boxes and labels. So we're going to put this to be an input image displaying a pill image, and this is going to be the classified image, also one of these pill images. We're going to have a button called classify, and when you click it, we want to say that, hey, use classifier as the function that we want to run, and give it the input image. As we see, classifier takes in an image, and that's where we're supplying the input. And then we see the output, so when we return the new image with the boxes on top, we want it to be populating this Gradio image object right here. And then to have something we can display without uploading our own photos, we're also going to use these gradio.examples, where we're saying, okay, we're going to take our example images that we loaded, and we're going to populate them in the input image, and then say that you can choose an example image. Now Gradio is a little wonky right now, so if you're also having trouble, you might have to comment out all of these things first, and just do Gradio app.py, and this will start the web demo on your local machine. And as we can see now, we can head over to one of these links, put that into our web browser, and we should only see this title. And then we'll have to go back and kind of uncomment all of this. And then if we reload the page, now we should see kind of all our elements pop back up again. And if you don't have trouble with this, good, but if you might have trouble, that's why we're doing the recomment and uncomment. And now we can see that we can do the classifications again. We can select an image, hit classify, it will run the model in the backend, and we get our detection. And if we go back to the code, we can see that here we can see the speed of the model and how much it took for example, inference, and the shape of the image, and so on. So we can try it with different animals and see how it goes. We can see processing. It took a little longer that time, and we can get our result. So there's a quick up and running tutorial to get you started with MegaDetector. And hopefully things like this could help actually rediscover animals that maybe were once thought to be extinct. Just this year, scientists rediscovered the South American tapir after 100 years of believed extinction. And using these camera trap networks, we might get a better toll on the current state of biodiversity, what species need more resources, and even rediscover species that we thought were extinct. Alright, so that was the MegaDetector and an introduction to camera traps with machine learning. Thank you so much for watching. Bye.